Josie's on a vacation far away. Come around and talk it over. So many things that I wanna say. You know I like my girls a little bit older. I just wanna use your love tonight. I don't wanna lose your love tonight.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, coming in with the classic Your Love by the Outfield. We're not going to lose our love tonight because we have a love of mathematics. So let's get to it, shall we? I think that we should. Let's make sure we pause that so we can enjoy a little bit at the end. This might turn into 2 videos. We shall see. We are going to expand and factorize exponential expressions like 7 to the x. In other words, terms or numbers or whatever that have an exponent, a variable in the exponent. I always do that. So the expansion is the same and factorization is generally the same. So if I had to expand and simplify this, here's what I would do. I'm just going to distribute 5 to the negative x through the parentheses. So that is going to equal 3 times 5 to the negative x, right? Here, times 5 to the x. I just put them together there. Let me put a dot in there just to be consistent. So 5 to the negative x times this guy, minus 5 to the negative x times 5 to the 2x. And this is not a big deal. We're just applying our rules of exponents. So this becomes 3 times 5 to the negative x plus x is 5 to the 0 minus 5. Let's see, to the negative x plus 2x is just x. So this becomes 3 minus 5 to the x because 5 to the 0 power is equal to 1. Giddy up. That was painless. All right, so now we're going to do a couple here. We're going to expand, okay, 2 to the x plus 3 times 2 to the x plus 5. We expand as we normally expand binomials. 2 to the x times 2 to the x. And, you know, I'm thinking that you're going to get to a point where you do not have to write out step by step. I'll go ahead and do it for now. 2 to the x times 5 plus 3 times 2 to the x plus 3 times 5. I can't believe I just wrote 3 times 5. So 2 to the x times 2 to the x, we're going to add those exponents. So that's going to be 2 to the 2x, not 2 to the x squared, no. Plus, let's see, 5 times 2 to the x plus 3 times 2 to the x is simply 8 times 2 to the x plus 15. Could that have been any easier? Now, we could simplify it a little bit further here because this 2 to the 2x I could think of as 2 squared to the x, couldn't I? Plus all this stuff, and then I could rewrite this as 4 to the x, finally, plus, what else could I do, boys and girls, if I wanted to have a base of, oh no, let's get back here, I just saw that. I could think of 8 as 2 cubed, couldn't I? 2 cubed times 2 to the x plus 15. So I could also write it as 2 to the 3 plus x plus 15. Okay. Simplified just because I have a single base. At times, maybe you're going to want to leave it in this form. None of these are inaccurate. It's just a matter of being comfortable with being able to manipulate these as you need, as the situation presents itself and how you might need, what form you might need it to be in. So 3 to the x minus 3 to the negative x squared. This is in the form of, well, no, it's just that. So this becomes, I'm going to go ahead and write it out. 3 to the x minus 3 to the negative x times 3 to the x minus 3 to the negative x. So this becomes 3 to the x times 3 to the x. Can we just go ahead and think about this as 3 to the 2x right away? We're just going to add these. 3 to the x times negative 3 to the negative x is negative 3. X minus x is 0. Minus 3 to the negative x times 3 to the x, well, that's going to be minus 3 to the 0. And then a negative times a negative is a positive. 3 to the negative x, 3 times 3 to the negative x. We combine our exponents. That's 3 to the negative 2x. So I can rewrite 3 to the 2x as 3 squared to the x, or 9 to the x, minus 1, plus, let's see, 9 to the, what am I doing there? 3 to the negative 2 is 1 over 3 squared, so that would be, let's see, 1 over 9 to the x, or 9 to the negative x. I could think of it like that. And so we could simplify that as 9 to the x. Feeling like I'm doing something wrong here. No, I'm not. The book had it a bit differently. They started off as a minus here, and then the work they did a plus. So 9 to the x minus 2 plus 9 to the negative x. Okay, lots of different ways you could have expressed that. We are going to leave it like that. All right, next. Factoring. We can look for common factors, and then we look for other forms just like before, perfect squares, and the difference of two squares. So, part A. Okay, let's rewrite that. 3 to the n plus 3 plus 3 to the n. Okay, well, can't I think of that as 3 to the n times 3 cubed, this first term? Isn't that equivalent? Say yes. Yeah, it is. Plus 3 to the n. So they have a 3 to the n in common, so that becomes 3 to the n times 3 cubed plus 1, which turns into 3 to the n times 27. 3 cubed is 27 plus 1, so that becomes 3 to the n times 28. Nice. What about B here? 2 to the n plus 2 plus 8. Okay, so let's think about that one. How are we going to work that? Well, let's see. Can't I think of this as 2 to the n times 2 squared? I think that I can. I'm pretty sure that I can. What else can we do? Plus 8, right? And you might have been thinking, well, I could write that as 2 cubed if you wanted to, but I think maybe it would be easier to think of 2 squared as 4 times 2 to the n, times 2 to the n plus 8. And I can factor out a 4. 4 times 2 to the n plus 2. Shame on me for not putting my equal signs. Okay, and then you end up with that. Now, you would have gotten the same result if you factored out, if you wrote 8 as 2 cubed, you could have factored out a 2 squared. But we're not used to that, so it was a little bit easier to factor out the 4. C, 5 to the 3n plus 5 to the 2n. This looks too good to be true, maybe because it is. You should be able to, at this point, look and see, oh, they have 2n in common, but if you can't, this is equivalent to 5 to the 2n times 5 to the n plus 5 to the 2n, and then you can see it has 5 to the 2n in common, so that becomes 5 to the 2n times 5 to the n plus 1, which is perfectly fine, but we could also write this as 5 squared to the n power, 5 to the 2 to the n. Well, that would be 25 to the n times 5 to the n plus 1. either one of these is acceptable as being factored, the last two right here. Okay, so let's see what next and decide if we're going to, yeah, I think we'll do one more and save those last three for the next vid. Okay, so we're supposed to factor 9 to the x minus 4. Okay, well, that is the difference of two squares, boys and girls. 9's a perfect square and 4 is a perfect square. So let's just rewrite this for a second. This is 3 squared to the x, yes, minus 2 squared, okay? And I'm going to rewrite this as, this is not the difference of two squares right now because this is to the x power. So I need to make it squared. Well, isn't this equivalent to 3 to the x squared? Let's think about it. 3 squared to the x is 3 to the 2x, which I could have written 9 as 3. Well, yeah, I mean that it's equal to 3 to the 2x, isn't it? And then 3 to the x times 2, well, x raised to the second power, x times 2 is 2x. So it is equivalent, minus 2 squared, okay? So I have something squared minus something else squared. Well, that factors into, as we know, 3x plus 2 multiplied by 3x minus 2. And if you're not convinced, go ahead and expand it, and you'll get right back here to 9 to the x minus 4. All right. So here we go, 25 to the x plus 4 times 5 to the x plus 4. So we have a trinomial, and we're thinking of it, as the product of two binomials whenever you have a trinomial. You just have to figure out what your variable is, okay? Well, 25 to the x I can rewrite as 5 squared to the x plus 4 times 5 to the x plus 4. But I need the x to be, this term isn't squared yet technically, but if I rewrite it like this, like I did before, 5 to the x squared plus 4 times 5 to the x plus 4. Now some people at this point say just do a quick substitution because it's easier to factor. People get bummed out by using 5 to the x as the quote-unquote variable. So I'm going to let u equal 5 to the x. Okay, so then I have u squared plus 4u plus 4, which I know quickly factors into u plus 2 times u plus 2, or u plus 2 the quantity squared. And then when I'm done, I can just substitute back in 5 to the x, and this becomes 5 to the x plus 2 the quantity squared. So there you have it. That should be it. We'll make this part 1, and then we will finish up with part 2, but we will not finish up without checking in with the outfield, see how they're doing. They're doing great. And boys and girls, I am